All right, so we're starting chapter 5 today. This is section 5-1. All right, what today's focus is in on is simple and compound interest. Now, there are two different types of interest in real life. You have good interest and you have bad interest. Good interest is extra money that you earn for like putting your money into a savings account in the bank. When you put money into the savings account, the bank gives you money for putting your money into the bank, all right? Because they go and use your money and invest it in other places, and they make money off of your money, which is why they give you extra money, all right? That extra money that they give you for leaving your money in the bank is called interest. Their bad interest is like interest on a loan or interest on a credit card, where the bank or the credit card company charges you extra money for using their money. All right. So if you took out a loan for a house of, let's say, $100,000, you might end up paying $110,000 once it's all said and done, because the bank is going to charge you extra money for using their money. All right. So we have a couple of letters because we have some formulas today. Anytime we see the letter I stands for interest. That's the extra money that your account either earns or not necessarily loses, but gets charged extra as time goes by. P sub zero is your principal, all right? Yes, that principal is spelled correctly. It's not P-A-L. P-A-L is like the principal of a school. P-L-E is when we're talking about money. So the principal is the amount of money that your account starts out with. If you took and put $1,000 into a savings account, that $1,000 that you have in your account that you're putting into your account starting off your account with is called the principal. The R is your interest rate as a percent. You're going to want to convert that percent into a decimal. So if it was a percent of, like, let's say 5%, all right, we never want to use the 5. We want to make that into a decimal. You make a percent into a decimal, any percent into a decimal, by moving the decimal point 2 places to the left. So this really becomes the decimal 0.05 is really 5%. You would put a placeholder of a 0 right here. T is time. Always make sure that your units match. We're going to be mostly talking about years as our unit of time. But if they happen to say like 26 weeks and then they're talking about years, well, there's 52 weeks in a year. So really your unit would be like 0.5 years. So you just have to make sure that you're using the same units for time. P sub T, or P of T in parentheses, that's the amount of money in the account at a given time. Simple interest, there's two different kinds of interest that we're going to be talking about today. We have simple interest and we have compound interest. The difference between the two is that simple interest is calculated just based on the principal. How much interest would you get? Where compound interest is they're reinvesting or redepositing the interest back into your account, and then you're earning interest based off of that interest. So your interest is earning interest. You're going to have to calculate both kinds today. So you're going to see on these questions that we sort of have two sides to each. All right, there's really two different people that we're talking about in all of these questions today. We're talking about Sarah on one side, and we're talking about Warren on the other. We're only going to concentrate on Sarah. This lesson is a really, really long lesson if we do both. So if you look back into your hard copy of notes, you'll see all of them for Sarah and Warren, but we're only going to do Sarah, all right, to save a little bit of time because this lesson is long. So the formula for simple interest is I equals PRT. Interest equals principal times rate times time. The original amount that you put in plus your interest gives you your principal at a certain time period. So this is really the formula that we're really going to be focusing in on for simple interest, all right? It is your total balance. Now, the balance is if I go to a bank and I ask them, how much money do I have in my account? That is called the balance. So that is your principal at a certain amount of time. So this is your total balance. You might want to write down that formula because you're going to need this formula. All right, this is your total balance. That is the amount of money you have in your account at a specific time, equals the original amount, all right, the original principal. And it is plus the original principal times the rate. Come on, board. Times the rate. And times the time. So when we take a look at Sarah, Sarah has $400. That is our original principal, so P sub 0, that she deposits into a simple interest account. The interest rate is 7%. Now, that is your rate, but remember, we want it as a decimal, not a percent. So we need to move the decimal point over 2 places. So this really becomes 0.07. Write a function to describe this. So it would be P of T, all right, P of T, which is what we're getting here, the total balance at a certain amount at a certain time, equals the original amount, 400, plus, in parentheses, the original amount, 400, times your rate, which would be 0.07, times the time. Now, we're not given the time. We're just going to leave it as t for our function. So we can take and we can multiply 400 times 0.07. That is 28. So what we really have here when we multiply what's inside the parentheses is plus 28t. Now, we want to make this into the y equals mx plus b form. We want to make it into that linear form. So we're going to have P of t equals, we're going to switch them around, and we're going to say that it's 28t plus 400. That's our function notation. How much will be in her account after 10 years? Well, what you have to do is you have to take this 10 and sub it in for t. So we're going to have 28 times 10 plus 400. 28 times 10 plus 400 gives you that after 10 years, she would have $680. What type of function is this? Well, this function is a linear function. It is in that y equals mx plus b form. All right, that's what it looks like. Just as a rate, just taking a look at Warren for 1 second. I'm not going to do Warren. But taking a look at his rate, all right, that's 7.5%. Remember, you'd have to move the decimal point over 2 places, 1, 2. So this would become 0.075 as your rate. But again, you just sub in the numbers where they belong into the formula. So moving along with Sarah, how long will it take Sarah to reach $2,000? Now, the way that you're going to do that is we had that the function P of t, so the principal at a certain time period, so the amount of money at a certain time equals 28t plus 400. So you're going to do 2,000 equals, all right, 2,000, sorry, I went the wrong way. 2,000 equals 28t plus 400. So we subbed in the amount of money at a certain time, and we're looking for the time. All this is a 2-step equation. So minus 400 minus 400. So 1,600 equals 28t. Divide by 28, divide by 28. We get t equals 57.14285714, blah, 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 blah. How long will it take her to reach 2,000? Well, she'll have exactly 2,000 at 57 and maybe a couple months. Well, so looking at interest is only given, in simple interest is given at the end of each year. So it would take her 58 years to reach that. Now, 57.1 doesn't round to 58, but in the context of the question, for her to reach 2,000, you don't get paid simple interest until the end of that year. So therefore, that 57 and change would be 58 years because she get paid at the end of the year. How long would it take her to double her investment? So she initially invested $400. She initially put in. So double their investment would be $800. So again, you would take 800 and sub it into that function equation. So 800 equals 28t plus 400. When you solve that, you end up with t equals 14.2857, blah, 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 blah. So at the end of 14 years or the 15th year, that's when it would equal 800 at 15 years. So that's what simple interest is. Compound interest is a lot more complicated. Now, we're going to do compounded yearly, all right? Most bank accounts are compounded daily, all right? So that's even more complicated than what we're going to do. We're going to do compounded yearly. So what does that mean? Well, compounded yearly means that at the end of the year, you're going to take that money and reinvest it back into the account. You're going to add it to the account. So in year 0, right, it says a bank account starts off with 500, so that's your piece of 0, and earns 4% interest. 4% is your rate. That's really, when we move the decimal point over 2 places, that's really 0.04 as your rate as a decimal. So in year 0, the initial deposit, starting off with $500 into the account, we need to figure out how much interest we would gain. So you'd have to multiply that by 0.04. So the amount of interest would be $20 that they would get. And then to find the new balance, you have to add that to the original amount. So at the end of 1 year, you would have $520 total dollars. For the first year. So you're now starting off that second year with $520, earning 4% again. So this time you're going to earn $20.80. Adding that to the $520 that you started off with, at the end of the second year, you now have $540.80, reinvesting that interest that you earned. So now at the beginning of the next year, you have $540.80. You're going to earn 4%, so you're going to multiply it by 4% again. So that means the interest this time is $21.63. That's the extra money that the bank is giving you for keeping your money in the bank. You're going to add that to the original amount of $540.80, and now you have $562.43. So you're going to keep on increasing and increasing and increasing because you're taking this interest and subbing it back in, right? Adding it back to the account before you earn more interest. The more money that you have in the bank, the higher the interest. So we only had $500 in the bank. We got $20 of free money that the bank gave you. When we had $520 in the bank paid us more because you're getting paid a percentage of that amount. So you're getting $20.80 free. Then we have $540.80. So we have even more money in the bank. So they're giving us more money for free, that $21.63, and we can keep on going through that cycle. So let's look at the formula for compound interest. You're going to want to write down this formula at the top, please. P of t, all right, P of t. So this is your balance at a specific time, all right? This is your balance at a specific time. That's the amount that your principal is at a given time. Equals your original amount, your original principal, times 1 plus r, r being your rate. Remember, you need your rate as a decimal, and t is time. Again, normally we do years there. So Sarah has $400 that she deposits in a compound interest account this time. So your original amount is the 400. This time the interest rate is 7%. Move the decimal point over 2 places. So this interest rate is really 0.07. Sorry, 0.07. So we're going to write a function. So we're going to have P of t. P of t equals the original amount, 400, times, in parentheses, 1 plus your rate. Now again, be very careful. You can't use your rate as a percent. You have to use your rate as a decimal. So plus 0.07 to the t power. So we could take and we could add these two together to simplify it a little bit. So it would be 400 times 1.07 to the t power. That is your P of t. You are going to have to do that on your homework today. How much will be in their account after 10 years? So then you're going to take it and sub in a 10 for the t. All right, you're going to take and sub in a 10 for the t. You could just type that right into the calculator. When you type that into the calculator, because we're dealing with money, you would round it to the nearest penny. So you would get $786.86 after 10 years. So just by leaving your money in the bank for 10 years, that $400 became $786.86. What type of function is this? Well, because we have an exponent, right? Because we have this exponent, this is an exponential function. And that's what we're talking about in this chapter, are exponential functions. If we take a look at the next one, it says, how long will it take her to reach $2,000? So 2,000 equals, now this time, we're going to use our function again, but this time we're looking for the t. Instead of subbing it in to find the amount of money, we're going to sub it in to find the t. We already know the amount of money. So 400 times 1.07 to the t power. Now, the only way to do this, all right, the only way to do this is to use the graphing calculator. All right, so I need to pull up my graphing calculator here. So just give me a second to open this up and get to the right screen share. Sorry, it takes a second to open up. Can you see both the calculator and the thing and the flip chart? Somebody respond to me.
Yeah.
Thank you. Thank you. I didn't see the green circle like I normally do. So anyway, the way that you do this, all right, the way that you do this is we want to type in our original equation into our y equals. So not the 2000. The 2000 is really what we're going to be looking for. All right. You can't solve this. We don't know how to solve this. All right. That's actually what 11th grade math is. All right. It's called trigonometry. So what you're going to do is you're going to type in 400 times in parentheses 1.07, close your parentheses, caret button, and an X. Remember, we don't have a T, that's X. So when you go to type that in, you're going to hit second and table. And now we need to find where 2000 would be in that table. So we need to keep on scrolling down until we hit 2000. And I clicked too much, and now it's not going to stop. Stop. So where does it hit 2000? Well, where it hits 2000 is right. I went too far again. Where it hits 2000 is in between year 23 and 24. All right. So all that you are going to write is between 23 and 24 years. All right. Somewhere in between there, it's going to hit 2000. All right. Somewhere in between. That's how we're actually going to leave our answer. We can't figure out exactly when, but it's somewhere in between. That 2000 is somewhere in between year 23 and 24. How long would it take to double her investment? Well, remember, she initially invested $400. So doubling it would be $800. So where is it going to reach $800? Well, I need to scroll up a little bit. It's going to hit 800 if you look at the table in between year 10 and 11. That's where it would reach $800. So again, you'll need to use your table function to do this. And you just want to look and see where that total is in your table. So the other kind of problem that you're going to have looks like this, all right? You're going to be comparing simple interest and you're going to be comparing simple interest and compound interest. Come on. There we go. So when we take a look at our two formulas, we have, for the simple interest, we have P of T equals 28T plus 400. That was for the simple interest. For the compound interest, we have P of T equals 400 times 1.07 to the T power. Those are our two formulas. For the units, we're dealing with money and money. In your class kit today, that's already filled out for you. All right. The expressions are these two things. All right. The expressions are those two things. So for simple interest, we have 28T plus 400. And for compound interest, we have 400 times 1.07 to the T power. So what you would have to do is sub these numbers into here and figure them out. Well, again, probably the easiest way is just to take your table and sub it in. All right, take your table and sub it in. So I could go to my y equals again. I shouldn't have hid that. Come on. Sorry. There we go. So the easiest way is to take these and type them into your y equals. All right. Since the compound interest one is up there first, I'm going to do that one first. All right. So we could type that, we could sub that in and go to second and table. So when we go to look at it, we have at zero, we have 400. At 3 years, 3 is 490.02. For 10 years, it's 786.86, which is what we found before, by the way. And then at 20 years, you just have to go down a little bit. You could sub these in by hand if you wanted to. It's just easier to use the table and quicker. So at 20, it is 1,547. Now I need to show you something on this table. It looks like it's 0.9, all right? But if we tab over, we can see, and you can do this on your calculator too. If you use the arrow pad at the top, we can tab over. The calculator only has a certain amount of space in between. We need to see exactly what it is, so we need to tab over. It will tell you the values down here of the big long decimals. We want to round to the nearest penny. So where it looks like $1,547.90, it is not. The calculator rounded it to fit it on the screen. It's really 87 cents. So this is really an 87 here. Be very, very careful on that screen, all right? Because it looks like it rounds it. So just tab in there to see it for sure. When we go to the other one, remember that you can type in things at the same exact time by putting it in the y sub 2. So 28x plus 400. And I can go to my table. I'm really looking at the y of 2 column. So 20 is 960. So this is 960. 10 is 680. And I'm getting it from this red column. 3 and 0. 3 is 484. And 0 is 400, because that's what we started off with. So what's the difference between simple and compound interest? Well, the compound interest, you could see if we were using simple interest, after 20 years, you would have $960. Using compound interest, you'd have $1,547. So the difference is because that compound interest keeps on subbing back in, reinvesting your interest each year instead of taking it out. The compound interest, because your interest is earning interest, the compound interest would be higher, right? You'd have more money, right? It would be a higher amount. So that's what your stuff looks like today. Let's take a look at